Yes. Wow. So this is so unusual. I mean, after a whole year of billions of people using it, right, because of COVID and all, Zoom still hasn't figured out how to make the entry process less confusing, right? Because if you think about it, from Canvas, I have to click 5 different places and dismiss a dead Chrome window, a tab, Chrome tab, and all, right? All these things before I actually enter the meeting. But the right way to, especially if you have lots and lots of data and you can figure out, right? This is where most of the people are struggling. Then you put a little bit more, 1% more engineering effort into figuring out how to make it easier for users to just, come in and sample my app, please, right? But even though I'm the king, right, I want people to come and sample my kingdom, right? So to see how good it is. So that's the mindset, that pervades a company that's always after quality, right? Constantly, not just after money and glory and power and crowns to wear, but I don't care. Even if I've got the whole world, what I want is not the whole world, really, because the whole world is not enough, right? Because I have in my mind a vision of excellence, right? I think that is the bit that is missing in many product development efforts. The bit that is missing is, many people are good at following a calculus, right? That's what calculus is, right? In calculus and mathematics, right? You don't have to, every time you want to calculate the slope of a curve, a parabola, you don't have to resort to deep reasoning, because you can always arrive at the answer through deep reasoning, right? Because parabola has changes and all, like you can do these things, but you can say, well, instead of deep reasoning, which usually characterizes most of other math, right? All other math, deep reasoning characterizes. What I'm going to do is take that deep reasoning and take the part of the deep reasoning that obeys a mechanistic law, meaning that that deep reasoning is so predictable, right? So actually, this is actually very useful. I think if you're doing math or majoring in math, I think I might have talked about this to my daughter at one point too, and she thought it was really cool, because it helps in math, I think, right? The mathematical mindset is for calculus, right? People say, where's the reasoning? No, where the reasoning is saying that, okay, well, there's a lot of reasoning here, but these reasonings follow predictable pattern, right? If they're following a predictable pattern, then I can basically use them as bigger level Lego pieces in my thing, right? In my larger proof, I can just use that, because I know if someone challenged me, I can go in and prove it, because I know that is solid and predictable, right? So calculus basically comes from the Latin word calculi, right? Calculi means pebbles on the seashore. And if you think about it, pebbles are how ancient peoples, right, used to do calculations. If you look at the abacus, for example, right, which, because that's how all kinds of calculations started, right? Counting things, right? Pebbles. And then you look at these ancient civilizations, they developed these remarkable feats of intellectual achievement just by shoveling pebbles around, right? Which essentially, if you think about it, that's what quicksort is. This is the magic of quicksort, a log linear algorithm, which is like inconceivable for most people, right? That is where all of that comes from, just the abacus, right? Shifting things around, because we're talking about discrete space here, right? So calculus is essentially, what the hell is going on there? Yeah, okay. I need to press continue on the other Zoom window. All right. Right? So calculus says, all right, so all of these reasonings are predictable. So when you want to calculate the slope of the parabola, you don't need to resort to deep reasoning anymore. Just apply the n times n to the n to the x times x to the n minus 1 rule, right? Right? So you apply that rule blindly. Why does that rule exist? That is magic, isn't it? But we accept that, because that's what I think Mark appreciated the last time. It's rational magic, right? Because I think rational magic is, you just accept that as the truth, but that if you are challenged, you can go in and prove that it's true from the first principles, right? So there's a lot of rational magic in calculus that allows you to build bigger things on top of that, using the same kind of mindset. As long as you don't lose the mindset, you can apply it at any level, right? Whether at the level of bits and bytes, or whether at the level of complex logic. So that mindset is what, all colleges, all universities, all gurus, right, try to cultivate in people, is not really the mastery of facts. Individual facts can come and go, right? They change. Empirical things change. Empirical things change because of the material world, right? Anything changes, right? But the fact that you read into these things, they don't change, right? That's the good sense. And that is what all instructors, all professors try to instill. And where the hell were we going with that? You know, we talk calculus. Um, yeah, product development anyway, right? Yeah, so that thing, that idea, that mindset that pervades saying now, maybe that is the birth of wisdom really in everyone, right? When they start creating kick-ass products all of a sudden, it's really because now they're not following rules. They're saying, okay, well, there is this fantastic product out there, I need to emulate that, right? So maybe they'll try a very half-assed job, or they can never be as good as a fantastic project because that is their goal, right? But but they'll do something good maybe, right? But the people who actually go on to change the world fundamentally are the ones, I think, who have suddenly that birth of wisdom, where it says, I don't have these fantastic products out there anymore. I don't have these brilliant men, right? Humans, role models. I don't have them anymore because now I don't need any of them because I have a vision of excellence. So I don't care. I don't care. And I don't care if one particular path doesn't lead to it, because as long as I have a vision of the excellence, I can find another path. I never have to be wed to one particular path and say that is the only way to reach excellence, right? Which I would say, if that's the only thing I knew, right? So then I'm wedded to the path, not to the excellence, right? If I'm wedded to the path, I'll say that's the only path to the truth. Right? But if I'm wedded to the truth, I'll say there are many paths to the truth. All right. Anyway, enough of that nonsense. So where were we going with all this? All of this was started because of Zoom, and I didn't know if this was being recorded, and I had to quit. And then when I came back to Zoom, I had to go through this intricate dance, right, to get back into the session. And then I had to, and it triggered all kinds of these side effects on the iPad also. So that kind of derailed us for a moment, right? So I'm sorry about that. What time is it anyway? Oh, it's not 8:15 yet. Okay, all right. So we're still in blabber time. Okay, so we usually start coding at 8:15, right? Yeah, we start coding at 8:15. How about this? How many people? Why is it that a lot of people are missing in class today? Wow, what the hell? Hey, Mark, I shared something in chat. Hey, cool. Thank you, Mark. Thank you. All right. So what was I saying? Yeah, I don't know. Maybe we need to wait for other people. Maybe I just need to email these people. All these regulars, right? So some of the regulars are here, but many regulars I don't see, right? Sri Karan, what the hell is he doing? I haven't seen him for like 3 classes. Sri Karan, Isaiah was there, and he's not here today. Jacqueline, David. So yeah, I can see you guys, right? Because I can see what coordinates you occupy in my Zoom screen, right? 1,4 and so on, so like that. Until I that unfortunately doesn't work too, right? Because that's another thing that I'd like to stabilize, right? In a classroom, a professor likes to have, at least until they learn the names of these students, they like to have students in predictable places, so that it saves a microsecond. Hey, can you hear? Did you hear? You did? Okay. All right. Okay. So there you go. So there is a certain audio threshold. Okay. So if the train makes a noise less than a threshold, it's completely filtered by Zoom, which is really cool, right? I think we realized that last quarter or 2 quarters ago. I was talking and I couldn't hear myself talk, right? Because there was a train, not as loud as this, but I couldn't. But the students could hear me. Crystal clear. And then I listened to the recording that we got, and there I was clear too, and I couldn't hear the train, right? So Zoom did something very clever there that I really appreciated, is without telling anybody, right? So these are niceties that you just build in and say, well, there's all these background noises that I can easily identify with machine learning, right? So you can tell, right, from machine learning, even without even machine learning, you can match the standard acoustic patterns, right? So, and you can subtract it out. and it's doing all these really nice acoustic things. Yeah, we used to do fun things like that in the speech lab at SRI. So I used to work in the speech lab at SRI International a long time ago. And we used to do lots of really crazy and funny things, take songs, because that was a time when karaoke was basically taking over the world, like billions and billions of dollars there. And then we created a machine which would basically take any song and the lyrics and make a karaoke version out of it by by aligning the phone spoken the song the song with the lyric one by one, so we can have a ball bounce on the right thing to speak at each time, and then we subtract out. Yeah, that's where we're going. And then that wasn't the challenge, right? That is just speech recognition. The challenge was making it karaoke, meaning that there is a song, but we've taken out the voice track and you only play the music without the voice, and so we had to do a lot of really sophisticated and clever, but actually it wasn't so complex, but it was clever audio processing to get rid of the voice and only play the music. This is kind of funny. Hey, I sidetracked again by this train, derailed by the rail. Okay, all right, so anyone take the screen. I'm thinking what we can do is, hey, by the way, anybody who's in touch with the people that I mentioned before who are not in class, just rattle their cage, okay? So they can't just take off like that. You know how fast we're going right now. Yes, I mean, it's not like the first couple of classes where you're just working with binary numbers. So we're taking a program, and then, if someone didn't sit through Jacqueline's class, they would have been totally lost in David's class. Yes, because we basically took Jacqueline's program. There's no point in me. You can't make up after that. So anyone who basically says, I got these other classes that are taking up my priority, so has basically said at this point, okay, I'll just do up to class number 6 and take a pass. If you do class number 6, I'll pass you. No problem, right? Everybody passes. Because, pass basically means, pass in CS2A means that you are familiar with, programming concepts and what a language looks like, especially C++, right? You don't have to be a master. Nobody expects even a CS2A graduate to be a master of C++, right? Not even CS2C. You have to, because 3 months of anything doesn't teach you that, right? So I try more like 30 years or 3 years or something like that, right? So you have to be immersed in it, right? Like pickles. You can't put the dill and the vinegar and say I'm going to eat it like 10 seconds from now. All right, good. All right, so who is going to take the screen? I'm thinking what we can do. Yeah, we'll create a player class or something, player class. Oh, yeah. Okay, actually, you know what? Yeah, we're going to do a player class, and in the player class, we'll do a utility static method, right? A static utility method, just like we did for the other thing. I think we did so the previous thing, if you bring up that code, hey, where's Turkey? Yeah, see there, there you go. That's right. So I think what do we do? Display with effect. Display with effect. Right? He did that. Do you remember last class? So the one that rolled characters into place, and then the roll character into place was a static method, right? And it's a static method which is part of that family. And so what we're going to do in our player class today, we'll create a class called player, a tournament or game or something like that. Well, we'll have to think up something as we're typing anyway. All right. And then inside of that, it's going to have a bunch of utility methods, meaning that these are methods that are going to be called to accomplish things that we want inside of that class, but not relevant to other people. Does that make sense? Yeah. So we'll make them private utility methods. I want all of you to be on the same page before I even say anything else.
I feel like I've coded for like a good quarter of the classes so far.
Oh, I'm sorry, Mark. You actually cut out. Or can you say that again?
Is it just me, or have I coded for like a quarter of the classes so far?
I'm so sorry. I still cannot hear you. I bet your internet is totally screwy because even your picture is grainy. It's not like Chanyi. I can actually make out the outline in that cupboard also, right? But yeah, I can make out the outline, but it's all screwy. So I don't know. That internet connection is.
Oh well.
Can you type it in? Can you please type in your message in the chat? And I'll read it out. Can you guys hear me? Okay, Mark, can you hear me?
Yeah.
Everybody else? Okay, good. Hey, Mark, just type in your message in chat and I'll read it out. Something about
I can share the screen.
Got a quarter. I got a quarter of your message. You said something about a quarter and code, right? I bet so you must have said 10 words then. No, 8 words, because I got 2 words, a quarter of your message. Oh, I feel like I've coded for about a quarter of the classes so far. Oh, personally, I see. You're not speaking for everyone. So yeah. All right. Good, good, good. So you're saying you've coded a lot. So yeah, you would yield to someone else if they want to go. Is that what you're saying? All right, great, great. Okay. I for a moment, the confusion was because I wasn't able to figure out whether you're speaking for yourself or you're making a general statement for on behalf of everybody in this class, saying, hey, in this class, we hardly ever coded, or we only coded for a quarter of the class or something like that. Are you guys feeling happy enough that you're getting sufficient opportunities to code, right? Because what's a programming class? I went and did a programming class. How much you code? I never coded. I just listened to the professor all day. All right. So it's a totally useless programming class. So I want to make sure that everybody is happy enough that you got an opportunity to code, right? And most of you are getting opportunities to come up and code on screen. Yeah, but I hope you're all getting enough opportunities to code on your own. Yeah. Okay. All right. Thanks. It's very important. That's how it happens, right? Any art, piano or violin or any swimming, especially swimming, right? So you can't watch like a billion videos and then jump into the pool, right? Into the Mariana Trench or something like that. Okay. All right. So Mark says anybody else who wants to go can go. I think previously we've had success with all of you guys. All right, all of you guys.
I could volunteer unless someone else wants to go.
Who is this? Oh, Chris. Yeah, sure. No worries. That's great. Did you use online GDB, right?
No, I use Visual Studio.
Yeah. Okay. Great. That's even better because we get all these. They're all pretty much the same, mostly, except for.
Okay.
Great.
So you want to make this class called student, right? Or player?
No, student. All right. So let's think up a good name for this class. So what is this class going to do? So we want this class to be a team. Yeah. All right. Let's say class team. A team. What game are we going to call this? Sort team or something. Call it a team. It's just a team. We can rename it later. But because it's Visual Studio, you can always refactor it, right? All right, great. And put in aside, yeah. All right, great. So now we'll flesh out the team. So in our team, I'm thinking what we'll have is the team size, okay? So let's say we'll create a private instance variable of type size t and size t, all right? And call it size. That's the size of the team. Right. So you could say I want a team of size 4, size 5, size 6, and so on. It doesn't make sense. I'm just calling things. I'm pulling things out of the top of a hat, essentially. Right. So you guys have to stop me and say that's too slow or that's too fast. We got to be at the right speed because at this speed I cannot. It takes a great deal of effort on my part to match your speed. Right. Because we're both moving fast. It's very dangerous right? So we got to make sure we pull each other right into place. Are we okay with this so far? All right. So if I'm moving fast, all right, Chris may not know, he's typing, right? So someone else has to say, hey, Chris, hang on for a sec. All right. I'm trying to understand the previous thing you typed in before you type the next thing. Because that's usually what happens. What I found happens with students that I was watching, right? So in the STEM Center before, not 5 quarters ago, right? Just before the COVID, I went into the STEM Center and a bunch of students were coding and they were struggling. I said, can you just walk us through this code? And I was walking them through that code. And I was pretty much doing, I think, very much, it was only 5 or 6 lines, right? I said, I'm not doing this anymore. You figure it out and go. And I left. But during those 5 lines, I actually learned something because I'm pretty much doing very much similar to what I'm doing here. I was doing something very similar. And then as I was calling the code out, I was at that time, right? I was totally unaware of the speed mismatches, right? And also I didn't realize that there were some students who could actually type faster than I was going. And so I can't match up. And then I realized that as soon as I misstep, right? One misstep, that's all it takes. Right? Even if you're a competent coder, even if you're better than, faster than what I'm saying, if you're out of step, then it's really, well, maybe if you're out of step, you can wait, you can stop and wait. But if you've missed one step, you're basically finished at that point, because then what you have to do is the amount of effort you need to get back in the game is not constant anymore. it is exponentially growing, right? It's a vicious feedback loop. You think about it, right? That is the danger in everything, even in life. If as long as you're one step ahead or at the same step, you're good, right? If you step with a metronome, you can breathe, right? But if you're out of step, then you have to be resigned to put in some exponential. Why do I say exponential, right? Exponential because it's feed forward. Because not only do you have to catch up with a misstep, but you have to make up for that 1 unit of work that you missed, right? Which now is not 1 unit anymore. It is actually 1.x units, where that point x is greater than 0, right? Because what you missed capturing at 1.0 easiness before has now just become 1.01 easiness, because it's now further away in time. So now your total now is your catch-up effort plus that 1.01, which is like compound interest, right? And compound interest is exponential, right? So anytime you miss a step, you got to resign yourself to say, okay, I'm going to miss a step, but I'm prepared to put in an exponential amount of effort to come back to where I was. I don't know, it's a long-winded explanation, but I hope it helps you, right? And I think that's why, and I think, you know, in the STEM Center, that's what I learned, right? Because if I lose a student, I've lost them forever. I can't get them back. Not that quarter, anyway, not that quarter. All right. And so that's why it's very important. Anyone, right? And I can be Chris, because when he's coding, he can, right? And when you see that he's made a line and you're trying to understand it and he's coding the next line, and you're still trying to understand the previous line, then you're screwed, right? Because then at that time, you can pretty much forget about the program. You can say, I can watch a YouTube video and, you know, pause it and understand and go step by step, right? You can't follow the rest of it. Yeah, because and it's really, it gets harder and harder, and you're basically inflicting a great punishment on yourself if you don't tell one of us to stop. All right. So I don't know. Now we spent a lot of time on that one line. So you got a lot of time to, well, I don't know, maybe wasted, or maybe it is useful. I hope that is useful, right? Because I think that I found that with students before. All right, size T. All right, we'll do all the constructors and everything. Open a public section, right? Open a public section, right? And we're going to start slowly filling this in, right? Now, the first thing we'll do is when we, in the private section, let's also create a vector a vector of strings, and these are going to be our players, okay, eventually, or player names, right? So you can say player underscore names. Okay, good. And in our constructor, what we're going to do is resize that vector to be the same size as size, yeah, which has been requested, or it would be a default size. We don't have to do it now, right? I'm just talking, and maybe Chris can type. Without me talking, Chris can type through it, and one of you can either talk through it or follow through it, right? So I'm just going to describe what we want, and then, right? So in our constructor, there will be a parameter which takes the number of players in that team, right? The team size. So what the constructor needs to do is set the internal team size member to what has been passed in. That's step number 1. Step number 2 is need to resize the vector to have that many strings in it, because, you know, if you have that many players, you have that many names. Yes or no? Right? And after that, step number 3, it is going to iterate over the vector, okay? Each element of the vector name, right? And it's going to assign to that vector element a manufactured name using a static utility method we're going to write. We'll just, you know, a funny utility method, which will just manufacture a name out of thin air and return it, right? So you can say, give me a new name. And it's going to give you a new name. Well, we're going to use rand and all those things, right? And I think it's going to be fun. And and this is going to be very similar to what you're going to be doing in quest number 5, 6, 7, one of those things where you have to create a name. But we won't do that. What we'll do is something we stumbled upon last quarter, which was really cool, right? You know the 7 notes of the scale: do, re, mi, fa, sol, la, ti. Yeah. And you know, you get, so what we'll do is we'll just have a vector with those 7 notes in it: do, re, mi, fa, sol, la, ti, right? And then when you say, give me a name, you'll say, give me a name of 3 syllables or 4 syllables. Okay, let's say 4 syllables. No, 3 syllables. 3 syllables, right? You're just going to pick 3 elements randomly from this vector. So, you know, name maybe Dodori, or, you know, Dorito. You know, you come up with really cool and creative and funny names, right? We saw that last quarter. we didn't have a chance to play with it much, but we can try this again and play more. So this will just be a utility method that returns a name, which is simply made up of the note names, like do, re, mi, fa, sol, la, ti. And it's really cool, right? About this name, if you think about it, how many different names can you have? We think, oh, it's only seven notes, right? If you're constraining yourself to just 7 notes, how many different notes, how many different possible names can you have? Let's say four-letter names, right? 4-letter names. How many possible 4-letter names can you have? If you had each 4-syllable names, right? 4-syllable names. If each syllable can take seven possible notes, right? How many possible names can you have? Yeah. Why is it 26 to the 4? Oh, I'm sorry, Mark. Yeah, Mark is. I said letter. No, notes. Each syllable, 4 syllables. Each syllable can have 7 possible musical notes. 7 to the 4. All right, thank you. All right, so 7 squared is 49. So 49 squared is, slightly less than 50 squared. That's 2,500. So already you can generate, if it's 4 syllables long, you can have up to 2,500 names, 2,500 distinct, unique names, right? Just with, and the cool thing is you can actually have, you can dodo, re, mi, or something like that, right? Yeah, maybe that's a name. And the cool thing is if it's JavaScript, you can also play this. You can just download MP3 files, right? I don't know, do, re, mi. What is that? Do, re, mi. That's 1 second. All right, so you can download these little MP3 files and stitch together these names, and you can come up with the names like, hey, what's your name? And you'll say like C3PO, right? You'll just say beep, 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 right? And it's in the right frequencies, right? So it's actually speaking its name in musical notation. This is kind of cool, right? And so you can have people. So we can do that today. We can do that today. In fact, I can even show you how to do that in JavaScript. Oh, this is VS Code. If you're Chrome replete, you can just open up a JavaScript window. I can show you how you can turn these into audible names. All right, yeah, cool. We didn't try that last quarter. All right, so let's not do a default constructor, and let's just define a non-default constructor. Your team takes a parameter, size t, and desired size, right? Size t. Oh no, it's not desired size. You're going to say this is a size, okay? So size t space size, size t space size, right? So no, that's it. One parameter. That's and close it. That's a constructor. Do you want to do the constructor on your own, or do you want me to walk you through this, right? Or someone else can walk Chris through it too. That's perfectly fine. All you need to do is just those things, and for that generate the funny name.
Should I define it inside the class, or should I define it outside the class?
Oh, thank you for asking. Because it's going to do 3 different things. Do it out of line. Thank you. Very good question. Yeah, I think. I always ask that question every time I start creating, but do it before main, because what we're going to do eventually, I'll get rid of main, because, and then don't call it test.cpp, call it player.cpp. It will just do it all properly. Right? Or team.cpp, call it team.cpp. No, not test, call it team. And also the file also call it team.cpp with capital T.
All right,
yeah.
And then
can you rename the thing by double clicking the tab or something? Double click the tab. No, right click.
Okay. What do you want to call it? Team.cpp?
Yeah, we'll just follow the Java convention. No, uppercase team, right? Because it's a class. It's going to be a class. And in fact, make this team.h, and then we'll do the CPP in a separate file. We'll do everything. So even though it's really simple, it's like, that display thing where you only have like 4 or 5 lines, we'll do it the way in which it will set you up, give you a template to do bigger projects down the line, right? Because it's all going to be easy, right? So what is this file?
This team. So you wanted me to put the class in team.h.
Call this team.h. Call this team.h. Team.h, yeah, and then in here, what we'll do is just define the class and then we'll the implementation elsewhere. Yeah.
Should I just copy and paste it since I already have a team.h?
Totally. Thank you so much. I think that's what you were trying to tell me before, and I said no, don't do it. But we want a bunch of it here too. But that's fine. That's fine. No, that's good. What do we want? No, not C string. You don't need C string. Why do you? Yeah.
I think it was from a past. I was working on something else.
Yeah, don't worry. Okay. You don't. For now, I don't think we need stream either. We just need IO stream. Not even IO stream, right? We just need vector. Right, and then don't use namespace here because it's an internal header file. We shouldn't be using namespaces and all. So anytime we need to use something in the standard class, we'll explicitly qualify it with std. Does that make sense? Right? These are just good practices. It'll work even if we don't. It's good practices because it'll save you from being bidden in careless spaces and to waste time. Right? Yeah. Thank you. Yeah. Get rid of the spaces. Attach the string to the standard. I can see you're trying to follow the convention, but you'll find that convention takes up too much space because as it is, we're trying to shuffle. Yeah, so it's easier to get used to the other one earlier. Okay. Also, before the vector, you have std : yeah, because now you'll have class and you'll have like many pairs of colons and it'll get messy. All right, good.
And then we should define it over here, right?
And I said player names and you said underscore player names. That's really cool. And I said size and you said underscore size. Hey, thank you so much, right? These are things I would have come back to correct at a later point and you just made those changes automatically. So thank you so much for doing all these things. All right, so that is your header file so far. We're going to come back and keep on changing the header file, right? Because we're not going to do all of one and all of another, right? Now let's go back to the implementation file, which is your team.cpp, right? The first thing we want to
may include
team.h, yeah. Thank you.
Vector. We have to include vector for this one as well, right?
No, because team.h already includes it, right?
Okay. So
then, and in fact, what we need to do is go to team.h and include the include pragma once, so that you can include it multiple times or nested includes, and nothing will basically break your compiler, right? So in your team.h, put the pragma once right at the top, right at the top.
What was it?
Pragma, pragma, space one, once, ONCE, right? That is,
wait, how do you spell it? I couldn't.
CE. Yeah, no semicolon, and then people just put a blank line after that. What that means is that if this file includes another file, and that file includes this file again, right? If the compiler wasn't told, it could end up in a loop of includes, right? Because the compiler basically doesn't start translating until it's included all the files. Yes or no?
I think so.
All right, okay. So that's okay. You can smile too, because the smile is also an implicit no, right? And I know that because I do that all the time, right? So you can smile. So what happens let me also increase the size of the window because right now I'm only looking at 2 of you. It's better. All right, now I can. Well, I can't read the code so much, but I can trust Chris to, drive in the lane. All right. So what happens when you submit code to the compiler is that at the top of your source code, you have this thing called #include. Yes, that #include basically specifies a whole another file, right? iostream.h, right? And maybe you wrote a main.cpp, which was only like 4 lines long. But it had a very innocent #include iostream at the top, right? So your main is 4 lines long, which you wrote, but on top of that, you have a #include iostream.h, which is like 1,000 lines long. Okay, the compiler, when it sees your program, will not see your 4 lines. The compiler will see 1,004 lines because the compiler, in a previous step called the pre-processing, will take all of the #includes and actually physically include them in the file and make a massive, big ass file, which it will then pass on to the real face of the compiler. Okay, now, does that make sense so far? So if you have a #include, right? And then that file #includes another file, right? The compiler has to fill in this file before filling this file, yes? So what happens if you included this file and this included this file? So, it'll try to fill this file and this is, it's going to be, it's an infinite loop right there, right? And your compiler will break. So to get around that, a long time ago, we had these really, really ugly things, right? Saying hash define and hash if not def and do this. And you still do see that in Xcode sometimes. They're called include guards, right? And it's really ugly because you forget, you got to match up and, right? It's not an intuitive programmer like way of doing things. So people came up with a much cleverer way and nicer way of doing this. If you have an include file, just take hash pragma at the very top, and then you don't have to mess around with these hash include guards, right? The compiler will make sure that the file will never ever get included more than once, even though it may be nested includes. All right, does that make sense? It's a very important thing, and just one line, but I think it, knowing the reason behind that line is important because now you can leverage that line everywhere you want. Does that make sense to everybody? I don't know, nobody's.
Yeah.
All right. Okay, good. So we're going to go ahead, and if it doesn't, watch the video, and then you can also ask questions. Now, I can't see clearly because, well, let me get my dollar glasses. Because I reduce the size of them, not these ones. All right. Oh boy, if I don't use these for a couple of days. All right, good. Oh, great!
So we're setting
size.
So we're setting the data members underscore size to the size
Yeah.
size of the parameter passed in, and then we're setting the data member of player names and resize it to the size that's passed in, right?
That's great. One thing we want to do, and because it's a constructor, is what if size was 0, right? If someone says, give me a team of size 0, I think that you can Google this if you want. What happens if you resize a vector to size 0? Yeah, I think, you can resize to 0, which means it's the same as clear. That's fine. I thought it'll throw an exception because you cannot in C, in raw C, you cannot allocate 0 bytes, right? In C++ also, you cannot, in new, right? New, actually, I don't know if there's syntax even precludes that. But in C, you cannot allocate. You cannot ask the operating system to give me 0 bytes, right? So that will basically, it won't give you null, which it should, right? If you ask for 0 bytes, it can give you null. That's fine. But unfortunately, if you think about it, null is also a null pointer, which is being used to mean something else. So if you ask for 0 bytes, the correct answer to that question is not null. It is actually any byte, right? Right? If you think really, really logically about it, if you ask for 0 bytes, the answer is not null. The answer is any byte, because any byte, you have 0 bytes starting from there. You don't have that byte itself. You have 0 bytes starting from there. You have 0 bytes starting from any byte. So because it is the same, that is why 0 is not a, that is why 1 over 0 in mathematics is not a number. It's not infinity. People always make the mistake of thinking 1 over 0 is infinity. It's a big ass number, right? Right? That is a shortcoming of being unable to imagine that 1 over 0 is not a number. It has to be negative infinity and positive infinity at the same time, because the 0 could have been approached either in the positive direction or the negative direction. Depending on which way you go, it could be positive infinity. So if a number, if an object can be 2 different numbers at the same time, it defies the basic notion of what we call a number. So it is not a number. So from the same, you can apply the same kind of reasoning because it's a fundamental paradox, right? It's a fundamental paradox. So it can't be a number. So 1 over 0 is not infinity. It's not a big number. So, and where were we going with that? What was the analogy that led us into math? What were we talking about when we said,
Setting the vector size to 0.
Yeah. So you can't. That is why if you think about it in C, right? If you ask for 0 bytes, it will not give you null pointer. It will actually throw an exception, right? Exactly the same way as if you divide 1 by 0, it will throw an exception. It will throw an exception and kill the program, saying you asked me to do something which does not fit into the world I know. Because in the world I know, everything fits into one compartment. And there's this one thing here which does not fit into one compartment. Yeah, can you see that? Right? So that is why it is an exception. It is an exception to normal thing that we see every time. It's an
So do you want to set a Do you want to do a setter so the client
So
can't set 0?
yeah, and thank you, Chris. Right, so that's why it brings up this very important point that we have to have a setter which has to screen for these values. But in this case, we're going to bypass all of that, ignore all that discussion, because vector, C++ vector seems to be doing what we want, although it's not the right thing, right? Because if I ask it to size a vector to 0, it should throw an exception. Like C, it should throw an exception saying, I can't give you every number, I can give you one number. So it's not throwing an exception. And in fact, it is clearing the vector. Well, it's setting it to size 0, which I guess is technically right. Okay, so that's fine. I think it's, but the nice thing is C++ as a language now prevents you from asking for 0 bytes, I think, right? Which is kind of cool, right? In fact, this exceptional situation is now not even part of the language. It says it can be fulfilled by C++. It's not going to be part of C++. So you cannot ask, you cannot malloc, you cannot say give me 0 bytes, I think, right? In C++, unlike you can in C, which doesn't know how to handle it, right? Well, it knows how to handle it, right? By throwing an exception. Oh, all right, does that make sense? All right, so what we want to do is, this is fine. So it actually works for us. I was thinking before that what we need to do is, unfortunately, there was no way of catching this in the constructor, right? In the constructor. So if you have a setter, like Chris said, you can say, a setter can say, you asked me to set for 0, it's false, right? I'm not going to do it 0. Negative sizes, 0. So the setter can screen values and say bool, bool return, true or false, success or failure, right? But the constructor has no way of doing that. The constructor never returns a value. The constructor just makes the object. Yeah, so this is a very, very subtle distinction that lots and lots of people miss about setters and constructors. And I think it is very important, especially in C++, right? Java is a different question, because Java constructor can return a sentinel, right? Java and Python and all these other languages, when you create an object, you get return the object, yes? So you can say, give me a new thing, right? It returns the object because everything is a pointer. But C++ lets you create an object without having to create it on heap. You can create it on stack. Did we ever end up talking about stack and heap before?
I don't think so.
All right. What is it? Week 9. We'll talk about week 9. Maybe next week we'll talk about recursion. Maybe no, week 11. All right. So bring up in week 11. If please make a note. If I'll probably remember. If I don't, remember to remind me to talk about stacks and in the context of recursion, and then what stack is and heap is and where your different variables are stored and why they're stored where. Okay, it's actually very important to know, because that will actually make your programs incredibly faster, right? Because fetching things from one place is sometimes incredibly fast compared to fetching it from another place, even though they're both memory. So all of these things will start factoring into your programs, right? So remind me in week 11 to talk about that. So yeah, so setter can return a bool, but a constructor can't. And that is why what I do, right? This is what I do, right? Other people do it differently, and you can do it differently too. Every constructor I write, even though the constructor might be for a very, very sophisticated and big class, all right, I try to keep the constructor itself as simple as possible, right? I go to enormous lengths to try and keep it as simple as possible to, well, there's a very delicate balance you'll have to find. And unfortunately, you have to find it yourself, is how simple to keep the constructor. The idea is that if you want to make the constructor complex, you have to enable exceptions in your code. You have to throw exceptions from your constructor, because there is no other way a constructor can indicate failure. Think about it, right? Every other function you write in C++, you can mark it as returning a type, and that type can indicate whether it failed or succeeded. Yes? The constructor is the only function you'll ever write. Look, it's not destructor too, right? These are the only two special functions you'll ever write that will not return a value. So you have no way of knowing if it succeeded or not unless you made it throw an exception, right? And then you caught the exception in the calling code, which really gets ugly, right? So, and I don't like that. That's the reason I try to keep all my constructors as thin as possible, right? As thin, and it should do. You can look. I think Jack Morgan in a previous class, and I had a conversation about it on Reddit, right? And I'm pretty sure it's archived somewhere. You should, yeah. I tried to make the constructor do a measured little, if any, more than what it should absolutely do to get the object going. So this is fantastic, right? I like that constructor, and we've also checked, right? And we're not making a constructor that may break, right? Because if it was called with size 0, it may break, right? This won't break.
Does my setter make sense?
Do you have a setter? Oh,
Yeah,
that's
I
just
made
size. Oh, all right, good. Hang on. I'm going to increase the font. Okay. Oh, no. Let my glasses. Is it my glasses? Okay. Glasses. Okay. Cool. All right. About size. Yeah, that's fantastic. Can we refactor the code? That's great. That's fantastic. All right. Can we just refactor it? And it's going to be good because now it's on YouTube. You can watch them side by side and see, oh, this is better here and this is better here. So you can look at the pros and cons, and then you can come up with your own method, which takes, all right. So we're going to refactor it, and it's going to look slightly different. Okay. So right at the top, leave this below, open up a few lines at the top. Inside the function, open up. Yeah. And then we'll start coding the new way. And then you can, right now, what I tend to do, right? This is just my habits. You're free to follow. What I tend to do is, because I'm a lazy sort. Okay. I'm a very lazy person. I tend to take an out if ever it was immediately offered to me. Right? If there's an out that's available to me, I'll just take it. Bam, like that. I don't care about the rest of the world after that.
So if
and it's a hugely, it is a hugely mind cycle saving investment, right? So getting used to that is hugely productive, because then you don't have to worry about a lot of things. Because even though you may say, I'm going to use an if statement and do the things here, you cannot get rid of it from your mind. It's still lurking in there, right? If you think about it, that's what you'll see. However, if you just took the out and exited, you don't have to keep it in your mind anymore. So that is also the founding, I think that is also the intuition behind what I think is, there's a special kind of recursion, right? You'll implement recursion later, and functional languages later on you learn, right? So this is a special kind of recursion called tail recursion. Recursion, which you learn in 3 lectures from now, is very expensive, right? Anytime you can recurse, you should try and see if you can do it without recursion, right? It's nice to do it with recursion just to get an understanding and intuition about how everything works. But once you know how it works, you should always try and see if you can get rid of the recursion, right? Because recursion is good for humans, but bad for computers. Because recursion means calling another function. Calling another function means setting up a stack, pushing a stack frame, creating local variables, jumping to another part of the code, returning here, right? That's calling another function. And we do that mindlessly all the time. In JavaScript, Python, all these other languages, we use these single statements. They're actually single function calls many times, right? And we use it unthinkingly. So, and that's okay. That's okay. Because, most of these are measured calls, meaning they're not recursive calls, right? You're calling this, maybe that's going to call other, and so on and so. They'll all eventually return, right?
So Professor, was you're talking about something like this? So if size equals 0, just return false, else set the size and resize the vector, and then just return true.
Let's do something more. Do something more. Get rid of the braces around the return.
Which one?
Those 2 braces around the return, the first return.
Okay.
Yeah. And then put a blank line after the return false, right? Now that's done, right? That's done. Now get rid of the else, because everything else is an implicit else automatically, because that is what I mean, right? Now you don't have the if hanging over your head anymore. If is gone. So if you use the else, the if is still hanging over your head. Yeah. And you don't appreciate I don't know. So you don't appreciate the lightness, the unbearable lightness of being, as they say, right? So that small relief you get, by not being ensconced inside an else, even though it's going to do exactly the same thing, and and it's only 5 lines, right? You're in the else, and that small relief you get by just getting rid of the else altogether is actually something that you can appreciate and enjoy. Because that relief has a taste of its own. So, you see that now it's been refactored. Size equals size, player name. Good. That's all we did. No else, nothing, and it's simpler in my mind, right? So there's 2 ways of doing this, and you can think about it, and they're all computationally exactly the same. right? Exactly the same in terms of efficiency. In fact, if you look at the code, the compiler spits out on the other side. And this is the beauty of it, right? You take the code that Chris wrote and the code that I wrote, right? And you send it to a decent compiler, not any old compiler. Send it to a decent C++ compiler and look at the machine code that comes out on the other side. It'll be exactly the same. Because the compiler will basically digest all of it and factor it all into some internal tree, which is going to be exactly the same for both me and Chris. And that tree gets translated into machine code, right? Depending on whether it's ARM or Intel or something else, right? So it doesn't go from here to here. So that tree is going to be the same. So everything we do here is only for this side, for the human side of things. And that is where we have to get really, really good at, because the compilers are getting better and better every second, right? So we should not really be spending any mental cycles trying to do things the compiler can do better. So we should be trying to code always to make sure that humans can build on top of what we do, so that they can still bring their good sense to bear without having to invest their good sense in trying to understand what you did, right? That is the beauty of calculus. Great monuments have been built on top of calculus, is that it freed people, mathematicians, mathematical minds, from having to worry about the nitty-gritty details of lots and lots of these little proofs, saying, don't worry about these proofs, right? Build on top of these proofs, even bigger things, so that we can take care of these things, because we know for sure these things work, right? And that's how, computer science, all of these great fields, right? Every great field that you see, that's how they all grow, right? Organically like that, as long as we don't sacrifice our vision of the ultimate excellence for one particular path that leads to it, right? Because one particular path that leads to it also is bound to lead to success, right? Because it is a path that leads to it, right? But if we get locked into it, then we get a lot of stress, thinking that I got to stick only to this path. If I stray, I'm screwed, right? No, it's not like that. You can stray because there's many paths. You can find it at any time, right? So, all right. So that's all right. So let's go ahead and implement the yeah. Sorry.
Should we make like a default size?
Yeah, do a default size and do a minimum 5 players, right? For now,
Okay.
we can fix it up later, right? We'll fix up all these things later. Thank you so much. That's exactly how I would have done it to
Player size. Default player.
Team size. Default. Yeah, no, not player size. Player can be any size. You don't know. You can have really, really heavyweight person, who's the champion of a chess tournaments, right? So.
And then if set size returns false, then we just set this to default size, right?
No, constructor, that's what I said. You keep the constructor as simple as possible. Don't make any decisions, right? If you make any decisions, so Ken Thompson, who was one of the inventors of the Unix operating system at AT&T Bell Labs, he made a statement which is very, very wise, right? And I think all programmers should follow it, and I try to follow it as much as possible. It's because it saves you a lot of work, right? And a statement is so simple as some of these statements that Knut made, and so what is the statement? Okay. So I know what a statement is, but I was trying to think of the exact words, because sometimes it's not the content that matters; it is the way it was said that matters, right? So okay, I think I've got it close enough, right? I think he said, "Don't test for an error that you cannot handle." All right. Okay. I think this is what it is, right? He said, this is what it is. And it's so beautiful, isn't it? It's so profound. It applies to life also. Everything. It applies. So don't test for an error that you can't handle. Don't ask someone the truth if you can't handle the truth. Just live in your illusion. And that's basically what this means, is that in a constructor, right? If you're going to use a setter, and the setter is going to say, I succeeded or I failed, right? So it's given you some information. You test it. Are you able to handle it now in your constructor, right? If you were able to handle it in your constructor, why call the setter at all? You could have just thrown an exception right there, size equals 0, right? So here's where we bring, Ken's insight, right? Our, Ken Thompson's insight into our program design is to say, in the constructor, we want to keep our constructor as lean as possible. So let's not test, right? Let's not make any, because every time you test, you create 2 universes. Why does it say my internet connection is unstable? Are you guys hearing me? Can you guys listen to me?
You cut off for like a little bit.
Why is it that my internet connection is unstable? Oh, my phone's over there. So I was thinking I could fire up this Google Wi-Fi, which you use like once every 2 months or something, right? When your internet's slows to a crawl, you fire up Google Wi-Fi and it actually tells you if there's a particular device that's basically spamming your router, which can't happen. Maybe it's just Comcast. Oh, what was I saying before? Yeah. Ken Thompson's insight, right? So let's keep the constructor as simple as possible and not do any tests. We'll just say this is the size. We'll just test it. We will set it, right? And if the size is something that we don't want, we'll just set it to 5, right? If size equals, if size is less than 0 or size, you can do a two-way comparison here, right? Because I put a comment right there on top of the thing, right? In the first line of the constructor, say for to do for now to do colon to do TODO colon for now simply set size to something reasonable if it's if simply reset unreasonable sizes to 5 default size, yeah, something like that, yeah, default, yeah, to a default or something like that, yeah. All right, and then on the next line you can say if size is less than 0 or no, size can be less than 0, right? If size is, because size is unsigned integer, right? Because we use size t unsigned integer, we don't have to do two comparisons now, right? So and these things matter so much. Whether incredible, isn't it? What in an if statement, whether you do condition A or whether you do condition A or condition B or condition A and condition B, right? So whether you do 2 comparisons or 1 comparison matters such a great deal when you're trying to squeeze out every single, because if you look at really hardcore functions that everybody uses all the time, right? Any moment you think about any clock cycle you put your finger on, there's like a billion machines out there running this particular algorithm. So which means that this algorithm has really got to be squeezed. Every single clock cycle has to be. So those are the algorithms that people put a great deal of effort into squeezing every single clock cycle out of, to the expense of the algorithm itself becoming very obtuse, so that you need accompanying literature to understand the algorithm. Do you understand? Every other algorithm you can trade off. You can say, well, I need it to be more human readable than efficient, so you can always err, right? But certain algorithms like quicksort, for example, if you look at the library implementation, many times it won't even make sense unless you have some additional comments or explanation, right? Because they've cut so many fine corners that you can't distinguish, right? So
Professor, so for the setter size, shouldn't we check for if it's less than or equal to 0, then we return false because we can't have a negative size?
That's what I mean, right? If you say less than or equal to, if you don't have to have the less than or sign. Oh, I see. We still have 2 comparisons because you have equals to 0, right? No, equal. Let's say 0 is a valid team size. The only team sizes that are invalid are greater than, let's say, I don't know, some max team size. Define another max team size, const, and say 10 players, right? You can't have more than 10 players. So if it's greater than max, just reset to default. In fact, you don't need a max. If it's greater than default, set it to default. No, all right. If it's greater than max, set it to default. Right? We can have 2 numbers, right? If it's greater than 10, you can set it to 5. You don't have to set it to 5. All right. Now in your code, you can just say if it's greater than 10, you can completely forget about the less than or equal to 0. So you saved 1 comparison. In this case, it didn't really matter. But if you're writing a really tight loop for a performant code, you'll know that this matters, right? Making two comparisons instead of 1. Okay, all right, good. If size is greater than max, greater than max. You know what? It's not so warm. It is supposed to be a warm day today, so I left the door open. Just give me a sec.
And Professor?
Yeah.
So for since I'm making it a static const size, can we define it inside the constructor, or we have to define it?
Yeah, interesting, isn't it? Yeah, and that's one thing I didn't like. Maybe in later versions of C++ they fixed it. In earlier versions, you can't declare static const here, unlike in Java and other languages. You can declare inside of the class, even though the compiler can do it, right? Unless, but see, that's the thing, right? They made this exception saying unless it is a numeric type like this, right? If it's a number, you can do it. But if it is something, if it's a static const, but requires an object to be created, which means a code to be executed, essentially, right? It is saying if it's something the compiler can do, like take a number and put it there, I'll do it for you. But if you're going to, if you have a static const object, and in order to make that object, I have to call a constructor, and constructor's code to be run by the runtime system, the compiler can't do it, right? So so C++ used to impose on programmers to know this. So it said, oh, if it's numbers, you can do it like Chris did. But if you said if it's a string, do a static const string, it won't let you do that, right? Do it for now, we'll erase it later, right? Yeah, do a static const string and set it to hello. Right, I'm pretty sure VS Code will complain, right? Or not VS Code, the compiler will complain, and then I'll show you how to fix that, right? Yeah, some string equals. Is everybody okay? Well, hey Isaiah, welcome to class. You're late today. Are you here now? All right, I heard someone.
Sorry about that.
Okay, all right, good.
Yeah,
Hey, reply to my email, okay? Reply to my email.
I just now got it.
Okay, good. Okay, all right. So what do we do? Hey, it didn't compile. Oh, maybe you have to compile it.
It's a complaint. It says a member type of const SD string cannot have an in-class initializer.
Where I didn't see it. Where's the complaint? Oh, by the way, you have to get rid of your habit. Okay, you have a habit of putting two spaces around colons, right? It'll bite you in C++ because in 2B you're going to be creating classes and nested classes, and you have like 4 pairs of colons on the same line, right? So you got to get. What? I don't see the error. But where is the error?
It's right here. It's like,
oh, there it is. Can you mouse over?
Yeah, a member.
Yeah, okay. There you go. Yeah, see, that's what it means. It says you can't have an in-class initializer because in-class means the compiler has to do it. Yeah, at the compile time. And because string is not a simple object like a number, the compiler can't put it in there. It has to run code. The compiler can run code for you. The code is only run by by the target machine. Maybe you're on an Intel machine compiling code for ARM on a phone. Yes, cross-compiling. So the compiler has no way of knowing what a string is going to look like on ARM. Yeah. So yeah, it's very subtle, isn't it? And that is why, that is how we get to appreciate the power of languages like Java and Python and things like this. Everything at its own level. That's what I say, right? So because Java says there are lots of things that we can basically abstract away from you, right? Anyway.
So you would have to initialize outside the construct or the.
Yeah. Hey, thanks. I was going to do that anyway. Yeah. Thank you, Chris. Hey, but I don't know if anybody else followed you because is everybody okay with that? Is how you get rid of the error, right? So you would declare it out of line, because if it's out of line, it is basically a variable assignment. Think right? It's global, because in C you can do global assignments, right? It's a variable assignment, and when your program starts up, it's going to assign the values to all your static variables. Yeah.
Yeah.
And that's part of the runtime system. Right? And that's the first static variable. It's going to run that line. And so the runtime system will kick in and make a string and assign it. Yeah. But if you didn't know that, and if you came from a purely Python background, right? That's what I mean, right? If you came from purely Python or Java background to C++, and it is very reasonable, I guess, or understandable for someone to complain and saying C++ makes it confusing because it says some types can be assigned inline in class and some types can't. Whereas in Java, everything can be done in inline, right? So there's this confusion, but if you look at it from the other side, you're essentially saying, no, C++ needs you to know the distinction between these two things. It needs you to know the power of the compiler. It needs you to know what the compiler can do for you, and needs you to know what the runtime system can do for you, right? Because unless you were actually that level deep in the design of a product, you don't need C++. Just go to Java or Python or some other language, right? Once you've done all of that, once you're bored, not bored really, right? Once you've reached the limit, right? You've got some code that you can get to be as efficient as possible in Python, right? As efficient as possible in Python. You can't squeak out any more cycles from it. Then at that point, if your boss says, now, okay, good. Now we're satisfied that everything works, all these math libraries, NumPy and everything, good, right? We don't care about NumPy because it's already done in C++, right? So, but these other libraries you wrote, okay, now this is the time for you to go and fix those libraries, okay? Now, those libraries which you wrote in your Python code, right? You called in your Python code, but you created them in C++. Now is the time you go to C++ and try and optimize that code, right? After you, because now you say, now you've got to the stage, right? This is premature optimization, like Knut said, right? Is the root of all evil, right? Now is the time you say, right, I've got to the stage where I've got everything else sorted out. All this logic is now nailed into place and it's good, solid, running. Calculus is working, okay? Now I can work on the Riemann hypothesis, right? Or something like that. So you can, and you say, at that point, I don't know where we're going. This is that one single misstep about math. I don't know what we were talking about. I got lost. Anyway.
Also, Professor, for the so for the set size, are we only checking when size is bigger than the max team size? Is that the only condition we're looking for?
Later. Yeah, put a to do there. Put a to do there, saying for now, improve this later. To do improve this checking later. Does that make sense?
Yeah, makes sense.
That's how we end up doing most of our programming anyway, right? So we write a lot of to-dos, and then half of it we just basically just delete instead of to-doing, right? All right, okay, cool. That's.
No, I think we're working on the constructor.
Oh, all right. Yeah, it's. Yeah, all right. In the constructor, if it's greater than max, just we silently reset, right? Silently
so
reset.
Size.
Yeah. And then you can add the word silently in front of the in a comment above it. So so that
then would we, so it'd be
I think
size
equals default.
Default team size.
Yeah. And then yeah, insert the word silently in front of reset in the comment. Simply silently reset. Or you can even turn silent simply into silently. For now, we silently reset. Yeah.
And then we have to resize the vector as well.
No. You can leave that. After that, you don't need the braces. You don't need the braces because, and also that's another thing we'll get really good at is figuring out what needs to be in the brace, right? What needs to be, because if something happens in the brace and something happens outside the brace too, you can factor it out. Ax plus bx is x times a plus b, right? So previously, think about it. You'd have a vector dot resize inside the if statement, and you also have a vector dot resize outside. Yes, because what so now you say, oh, that's x common to both. I'll factor it out. That's called refactoring. Right, that is the real refactoring. Okay, all right, so that's it. So you don't even need the braces. On the next line, you basically say vector dot resize size.
Should it be in line with the size, or should it be?
I think you got a typo too. I think you need underscore size, right? Because you called yours underscore size.
Oh yeah, underscore size.
All right. So and then you can basically say vector dot resize. What is it? Vector? Oh, you can say this. Oh yeah, whatever.
Player names. Dot resize.
Is everybody okay with this? Yeah, I can see I can see Jinghang. Well, he was here before. I can see Isaiah and Maxim, right? So I need to know if you guys are okay with this, or you're just talking and Chris is coding and you guys are not with us.
I can see that.
Who said that? Jing said that. Jinghang said that. Maxim, are you here?
Yeah.
Yeah. Okay. Can you follow along?
Yeah, it's just that when I was trying to occasionally compile, it would give me errors saying, "Hey, I can't find either file."
Oh, we haven't started compiling yet. We're just creating the files. We'll compile very soon. Yeah, you're just one step ahead. Thank you. Well, but that answers my question, saying that you're okay. Isaiah is the only one who hasn't answered. Are you guys, Isaiah, are you okay? Are you following along? I know you're doing one of the earlier quests now. Okay, so we need to get that finished. But you also need to be comfortable. Everybody, right? Even those of you guys who aren't in class. There's a whole bunch of you who are not in class today, okay? Or maybe it's because it's a Memorial Day, that long weekend thing, and most of you are still in holiday mode anyway, right? Probably on a beach. So I think, so hopefully then I hope we can see a bunch of you on Thursday, right? So what time is it now? We do have time, right? How are we doing on time? Ah, we got time.
9:15.
We almost got to have more than a half hour, right? Oh, yeah, left. So that's. Are you guys good on time? Are we going too fast, too slow? That's right. I don't get any feedback, right? Most of the time, I'm just blabbering away. And
Yeah, it's okay.
yeah.
So should we resize? What should we resize the vector to? Should we say resize it to?
Oh
the
yeah,
default
to
size
underscore
or
size. To underscore size.
underscore size?
Thank you, Mark. Thank you, all of you guys. Yeah, well, anything you guys type in a chat, I only have a 50% chance of seeing, because sometimes chat messages come on my screen and stay for 1 second and then disappear. Sometimes one comes and then it rolls off, another one comes up immediately, right? So all part of interface design. You gotta think about these things. That's your constructor, right? But in your constructor, we decided we need to do one more thing. Yes. One more thing. In fact, I think you need to do one more thing in your constructor. What you need to do is let's call a helper function, also a private method, right? Create a new method, create a new private method. Private method. Okay, thank you. It's a method, and call it set player names, right? Underscore set player names, and you can say void, right? Void set player names, and let's say it takes a size t parameter and say it's number of syllables, right? Num underscore syllables. Yeah, I say num underscore syllables because you're not going to give it the actual syllables. You're going to give it the number of syllables to use.
So what was it? Num
underscore syllables. SYLL. Yeah, I think that's fine too. SYLLS. Yeah, that's fine.
Should this in the public
Or ABLES.
private?
Lots of people aren't familiar with syllables, right? So the word syllables. SYLLABLE. Able. Still able. Syllables, right? So a syllable is a fundamental unit of pronunciation, right? All right, great. Now, what we're going, and it needs to be underscore set player names because it's a private method that's only visible to us. Yes.
Okay.
Is it going to be? Yes, I think so. Well, let's not let main call, right? As only the constructor and the set. Right now, let's define this method. Okay, let's define this method. By the way, this is a header file, right? Is this a header file or implementation file?
This was the header file.
Okay, now let's implement this. Let's implement this and say, and by the way, you got the spaces around the colon, double colon on the previous thing too.
Oh yeah.
No, team, double colon. Set.
Oh yeah, I keep forgetting. Yeah, it's team.
No, we'll get to a player pretty soon. And then also double space. Yeah, these live coding classes are pretty good practice for you to break that habit when you're in C++ mode. All right, so even the previous function also.
The team one. Yeah.
The constructor or the set size.
Yeah. All right.
And then also for the constructor.
Oh, I didn't realize that. Okay, good. All right. So set player names. All we're going to do now is iterate over the vector, okay, and set the player names by calling another static helper function. This is going to be our static helper function. Okay. So here, this is really nice. I like this because now what we're doing is creating a class. And the class has a helper function, which is not a static function. It's a helper function, which is going to just set name. Yes, are you guys okay with me on this? We're creating a helper function called set player names, because that's not a real function. It's not visible to the user of team, right? It's not visible to main. Is everybody with me on this? Are we cool, right? This helper function is a private function. It is only visible to the class. It's not visible to main, right? However, this helper function is also going to call another helper function, but that helper function is not attached to the object. It is a free floating static helper function. Okay, and you'll understand this after we, I should have talked about this after we implement this. Okay, so all right, so set player names. All right, so and it's void. That's fine. So all you're going to do now is iterate over the vector. Right now you can say for size t I equals 0, I less than underscore player names dot size I plus plus, right? So iterate over the vector.
I is less than what was it? Underscore size, right?
No, underscore player names dot size. Underscore
player names
underscore
size.
player names. No, I think it's underscore. Yeah, dot.
That size, and then I plus plus.
Yeah. So by now, I hope every one of you is so comfortable with the for loop right? That as soon as Chris starts typing out for size T, you already know what the entire line is going to be like, right? So that's the stage you need to be at this, week numbers 8 or 9, right?
And then so at player underscore names at I, we're just gonna call the helper function.
Yeah,
the one that says the name
okay.
each time, right?
Yeah, and now you say team, because it's a static method, it's not attached to an object, you need to attach it to the class, all right? So it's a team, double colon, all right?
And then we
Now
just
break your
the
habit
name,
and
right?
go back. Yeah, okay,
Yeah.
right? Now and again, it's a static method. So, and see, that's how programmers make out these things, right? When you read that line, you see it's a static method because it's being called with a class tag, right? It is a private method because it has an underscore in front of it. Okay, and it takes a parameter. That's how it's going to be, right? So you say underscore, make random name, make underscore random underscore name, make musical name, right? Make musical name. Call it make musical name, right? And then open parentheses, and you're going to pass it the number of syllables.
Okay. Oh, okay. Yeah, I see.
All right. Now you don't even need those braces. You don't need the braces around the for loop, right? So you can get rid of that. And it's also a for one line, right? One line. That's it. You're done. All right. Good. Now what we have to do is implement that function that Chris just typed. Yes. So let's go back to your class and add.
So it's going to be a type of string,
declaration, right? And it's a static method, so you got to qualify it with static.
Okay. Static. It goes before the type, right?
It goes, yeah, but these things you'll find out, right? Even if we don't find out now, after you compile, the VS Code will tell you, and you'll find out.
It's going to take in the size of
size T. Oh
yeah, size T, and then which we
just
call
call it
the
syllables. Yeah.
syllables.
Yeah, and then string needs to be standard colon string.
Oh, yeah.
Right. So far, is everybody okay?
Yeah.
All right. Now we can go back to that implementation file and we can implement this method. No, we'll do it in the implementation file, in the CPP file.
This is a CPP file.
Oh, this is a CPP file. They all look the same to me because when you switch, all right. Good.
String team underscore make musical name.
Now the funny thing is, because of the way the compiler does these things, maybe this is something the standards committee has to revisit, right? You don't put the word static in front here. So when a programmer looks at this file, they don't know immediately that this pertains to a static. This does not require an object. Do you see what I mean? So what we do to get around that is above that function, insert a comment for now, just saying static, right? Above the function, yeah, one line, yeah, and say this is static or something like that. Yes, static. That's fine. So that we know, right? This is a. Now we know that this is not attached to an object, right? Now, yeah, musical syllables here and equals, and then you can have do, re, mi, fa, sol, la, ti as individual words in here.
Should be all be lowercase.
Make it all lowercase, yeah. And then when we make the name, we'll convert the first letter into uppercase. Yeah.
What were they again?
Fa, F-A, comma, so, S-O, and then la is L-A. I think T-I, I think it's T-I. Everything is 2 letters, right? Yeah, much better. Okay, all right. Now, all we're going to do is inside of num, so on the next line, you're going to say string name equals some blank string, right? And then you're going to build it up, syllable by syllable, right? So string name equals blank.
So string name equals just an empty string.
Yeah.
And then we're going to make a for loop creating that string, right?
Yeah.
I equals 0. I is less than number of syllables, right?
Yeah. Is everybody following along? Anybody is welcome to call out the code for Chris to type, and then he will type at your speed. Okay. If you think this is too fast, you got to tell Chris. You can tell me to pipe down, right? I won't talk, and then you can talk, because I think Chris can pretty much fixed. So if you, right? So you can call out the code that Chris will type. Are you, Chris, you okay with that?
No, yeah, it's fine.
All right. So is everybody okay with that so far?
Yeah.
Everybody in step. Okay, good.
So
All
does
right.
anyone want to tell me what to code?
So it's string name plus
So what was that?
is string name plus equal.
So string name plus equals. Since we already initialized the string here, we don't have to put the string anymore.
Oh yeah, name plus equal. Like, do we need to random select the syllables from the?
So you're saying musical syllables,
Yeah.
syllables, and then we want to select a random index of that vector, right? That's what you're
Yeah, I
saying?
think yeah.
So that would be rand modulo and then musical
Musical lens musical. Yeah, musical.
syllables dot size.
Yeah, size.
I think that should be it.
Yeah.
I think so. In fact, you don't even need the braces. Is that it? That's it. Set names. That makes a name. And you need to return a name, I guess. Yeah.
Yeah,
Oh, yeah,
that's
true.
the name. Absolutely. Yeah. And that's it, I think.
Now here's something we can do. Now just create a main in a separate main.cpp file in which you include these files. And all you're going to do is just test out this method you've written by printing out a bunch of 10 random names, right? After calling srand. This is a nice little exercise for you guys. Is that okay?
Yeah.
Right, so that's all you're going to do. So that's how we do it, right? One step at a time. We test each step before you move on to the next step. Now we want to test that function and make sure our name generation is okay.
So we just have to include team.cpp since team.cpp includes team.
No, never include a CPP file. Right? That's a mistake that many CS2A students make initially, and you'll find out. Never include a CPP file. Only H files can be included. You can include a CPP file, but it's really, really messy. Right? You got to know exactly what you're doing.
Oh, I spelled it wrong.
And then no semicolon after the hash include line. I can step away, right? I think I don't want to cramp your style. What I'll do, I'll step away for a couple of minutes. Is that okay? You can call out to me. If you just call out to me, I'll come back. Just play around with this. Get some random names, and then maybe if you, what time is it now? I think we have time, right? Because we're going to play with this for a couple classes more. One thing you can do is see if you want to download do.mp3, ray.mp3. I'm pretty sure there's tons and tons of these files around on the internet, right? And make sure that each of these files shouldn't be more than 300 milliseconds, right? Because you want to fit 3 of those in. Because if I say John, I think I say John. Okay, well, I say it's 300 milliseconds per name, I think, because John sounds like 1 second, right? So I think 3 John must be 300 milliseconds. So a name should be 300 milliseconds. So which means that if you, it's a 3-syllable name. John is 1 syllable. Okay, let's say it's 300 milliseconds per MP3 file, right? So find a do.mp3 that lasts exactly 300 milliseconds. Or you make one in GarageBand, right? It's very easy to make. Pick your favorite instrument, make that, right? And you can create the 7 MP3 files, and I can show you how to. Anyone says my name is Do Re Mi, right? And then the other side says, oh, your name is, and then plays that note, right? Bam, 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 right? And then you can play with these things, right? I can show you how to do that. Have fun, basically, right? You only learn programming when you start having fun, right? Until you start having fun with programming, you're just not learning programming, right? You're learning something else. I think, or you're learning to do something because someone told you to do it. All right, I'm going to step away, and then just call out to me if you need me to come back. Okay, we have time and plenty of time for you to play around. So you guys are doing great, and Chris is doing a fantastic job driving too. So you guys are great. Just call me if you need me to talk.
Okay, sounds good.
Right.
All right. So does anyone know what they want to do?
Do we just call a make musical name function?
But it's in private, right?
Oh
This is
yeah.
the class right here.
Yeah. We cannot call it from main.
I think the goal is to make 10 names. So maybe we start by declaring a vector, then start populating it by calling the function.
Or shouldn't we just make a team object, since that's how we could call it from the main?
Yeah, sure.
So team, what do you guys want to call the team? You guys have any ideas?
Test, because we're testing it, making sure it works.
All right, testing. And then since we only have a parameter taking constructor, we're gonna have to give it a size at the start. So let's just give it a size of 6. So our constructor just sets the size, and name.
Maybe we can just copy and paste the name, make a make musical name, and then call it from main.
I think we need to set player names at some point, right?
So set player names is a private static method, so we wouldn't be able to call it from main.
Oh, that's right. So do we have a setter?
We have a set size.
Oh,
Okay, maybe we need a setter for make musical name then.
So bool set syllables,
Yeah.
size t, syllables. And that would be in the team.cpp file. So bool set syllables.
Also, FYI, you're doing that thing again.
yeah.
Oh, true, yeah. Okay, and then it's gonna be just like similar to this set size.
Yeah.
I mean,
And
couldn't you
so-
just feed it to set size or something?
Well, this is the player size, and I'm pretty sure we could have any number of syllables for our name, or I'm not sure if the professor mentioned anything about that.
Yeah, maybe just greater and or equals to 0. Greater than
So
0.
so you're saying if num syllables is greater or equal to
What I'm saying is
0.
you've kind of already done this, right? So we just feed it the private function, or am I wrong?
So you're saying to call the private function from set syllables?
Yeah, in this case, or does that not
'Cause
work?
I think because if that were the case, each name would be the size. Each name would have the number of syllables of the size of the vector. Because right here we're saying the size of the vector, right?
Okay, I'm mixing things up. Sorry. Go ahead. Yeah, no, you're right.
And now we're making name. Yeah.
So number of syllables. So let's just say if syllables is let's just say greater than like 10 or something. I'm not sure. Then return false. Else then well, that makes we would need another private data member of number of syllables, right?
Yeah. Yeah.
Okay. So static. No. So size t underscore num. Then if it's true, then just set num syllables equal to num syllables. Then return true.
I think we can like make a private names set name or name.
Oh yeah, true. And
Yeah,
then
yeah.
so that would be so set
It's static name, I think.
so you want to make a setter, right, for the number of syllables for each player, or what are you talking about? Because I think this would be our set syllables for each name, right? So this is kind of like our setter method.
Yeah, yeah.
Let's see.
But we still need a set name for
So set name.
I think in the public, right?
What's the setter? So shouldn't it be in the private?
Well, the setter has to be public or it don't work, right?
Yeah, yeah. Setters need to be in the public.
Otherwise,
Because we need to get the name, not the syllables. Right.
I think this would be get set name, right? Because we're basically doing the same thing. But we would need to call this make musical name. Does that make sense?
Oh, so you want to make a public set make musical name then?
Oh yeah, yeah. It makes sense. Yeah.
Okay.
Yeah. So and it returns a string, so it's set musical name. So it has to be in the public, so it can be called from main set musical name, and it's gonna take in size t number of syllables.
We forgot the underscore t.
Oh, true.
Yeah. Okay. Great.
T. And then I'm pretty sure this could just be. Actually, never mind. Is this even relevant? Do we even need it? Because it just sets the number of syllables.
Yeah.
I'm not sure what it does, honestly.
Yes, I don't think we need this, to be honest.
We don't need it.
So then set syllables. I forgot the standard namespace. String, set musical name, size T, syllables, and then that should go here. So string team
Set musical name.
set musical name.
And size T num syllables.
Size T num syllables. And then so set musical name, and then we from here we just
Yeah, you call.
make
Yeah,
music.
call them.
Call.
Yeah.
You just gotta feed it num syllables. Yeah.
And so return team, make musical name. Name, and we just pass in the number of syllables.
Yeah.
Does that make sense to everybody?
But it only makes one name, but we need 10 names.
Well, in the main, you can.
Yeah, we could just call it 10
loop over
times.
it.
Yeah, we
Yeah.
can create a for loop, call it 10 times.
All right, so for int I equals 0, I is less than 10,
And
I plus plus. Then we're gonna call it so team set musical name using, and then it creates it once each time, right? And then
Yeah.
it needs a, so let's just say rand modulo 10.
Yeah.
All right, but we want to put that somewhere, right? So the.
Say out.
We
Yeah.
could just see it out.
Okay, yeah.
Yeah.
Just to make sure everything works. All right, let's put bets on whether or not this compiles the first run. So it looks okay.
Set musical name, non-static reference must be relative to data object. Oh, we need to make it a static since it's since static methods don't need objects to be called. And string set musical name. What's wrong with
What's
this?
wrong with the
What?
Oh,
right.
Standard.
Yeah.
And main.cpp.
Oh,
Here we
we still
go.
need to return 0.
Oh, true.
Yeah.
Return 0. All right, see this compiles.
Hope it can run.
Oh, interesting.
Oh, it says I'm pretty
Unsigned
sure
wrong.
it's
Unsigned
When did we call along?
What?
It's in the main. Or wait, reference.
Is it something with to do with what we passed in here?
Set musical name. So I see.
LD symbol not found for architecture x86.
Team unseen. Maybe we can try like run outside of the for loop and then use the assign run outside
So it's just
the
yeah.
for
So
loop.
size t rand size equals
Yeah.
and then we just call it just
Run size.
then we just rand, yeah, exactly.
That is not where we're expecting the, oh, huh.
Maybe we should call Professor back. Oh, it's
No, this is something different. I'm going back to the.
Yeah, he's just doing some file navigation. This is the compilation
Main
step.
.cpp. It didn't give me it gave me an error the last time I ran it, even with the rand size there. So if you want me to call the professor back.
Yeah, it's not where I was expecting an error, honestly.
Professor, could you come back?
Maybe if we need to use the int function on the rand.
int.
Yeah. So
Yeah.
like on line 11, after the equal sign, put int open. I don't actually know
Oh,
if
yeah,
this
we
works in
have-
C++, but
Oh, you want to
Sometimes-
cast it to an int?
yeah. Since we're talking about a size t, which is your
I
unsigned
think it's just
integer,
like
right?
int, right? And then
Yeah, like that, and then
and then you would just cast this into an int.
yeah. I don't think you need
Great,
the parentheses around the int declaration though.
Someone asked me to come back. Chris asked me to come back.
Yeah, so we were trying to set the musical name, and then so we made a static method called musical name, set
Oh,
musical
okay,
name,
cool.
and then we give it a random
Yeah, we
size.
can run that.
So this happens when we try
Oh,
to
wow,
compile it.
10, up to 10 letters long? Okay, all right, good. I'm gonna reduce the size of, increase the size. Okay, some of you are dropping off. Okay, good. Where is your line? Where are you compiling it? Oh, you know, now you can't just compile main.cpp. You have two files, right? You have main.cpp and team.cpp. You got to give them both.
So it would
And
just be
also,
space and then
don't hit enter.
team.cpp,
Yeah,
right?
and then space -o. -o says don't create a random executable file called a.exe. Create a file called team.exe or something. -o space, and then say chris.exe or whatever it is. Your favorite name. Yeah. Okay. All right. Now, if you hit enter, it'll create a file called chris.exe, which you can run for your program. No. Oh, damn. What the hell is it?
No.
Right.
18 errors generated.
No, that's okay. No, it's probably something very, very simple. Let's just go to the first place where the error happens. Unless the classes change so much. Where's the first place the error happened? The first line. All right. Hang on. Implicit instantiation. Oh, string. It doesn't know about string. Go back to your.
Maybe you need to include string.
Which file is it saying the error is in? Team.cpp. Team.cpp. Go to your team.cpp. Why does it know about string? Go to the standard string. No, line number. No, up. Oh, there's a bunch of things here where you're using string and not using standard string.
Oh,
Oh,
true.
you know what?
Yeah.
No, it's going to be hard to find. Just using namespace for now. Okay, right at the top, and then later on you can fix it. Okay. All right. Now go back to your console. You should just be able to compile it. No, not this. Down arrow.
This one?
That one. Yeah. You still have the error?
No, it's compiling. Oh,
No,
they
you
gave
still
me
have some
14 errors now.
No, go to the top. Go to the top. Usually the first is what the thing is, right?
Might be easier if we CLS and then re-execute.
Yeah, clear and run. Yeah. That's why on the questing side, this was a change I made 2 quarters ago. The build.
Try down arrow.
Yeah, the build error. I just show you.
I tried down arrow. It's still not working.
Yeah.
So I need to go back to the.
Did you run it? Did you compile it?
No, not yet. What do I have in there? So
No, you can up
G++.
arrow. You have up arrow. The line.
I tried, but it wasn't working.
Wow.
I mean .cpp and then team.cpp, and then it was -o and then chris.exe.
Yeah. All right. Let's see. All right. Now go to the very top. Now that should be your first error. All right. Implicit instantiation of string in team.cpp. Did you not save that file? 30. 28.
Oh, every file is saved, I'm pretty sure.
All right, let's take a look again. Hang on just a sec. Line 38. What was the first one? Line 30 and 28. Okay, line 30. Okay, so it says it's returning a string and you're assigning it to a string. Num syllables. Okay. Now, where is the declaration for that function? Make musical name. In your
Make
class
musical
file. Let's take a
name.
look at your class file. Make musical name.
It's right here.
Static. Okay, that looks all right to me. And where's the definition? Where's the definition of that function?
And team.cpp make.
Oh, this
musical
is
name
it.
here.
This is it. I see string and team colon make musical note. All right.
And I'm gonna have to go. So would I just share this on Reddit?
Yeah, you can share it on Reddit. And the error is, yeah, you can share it on Reddit. If someone can pick it up, I can debug it with you for the rest of the class, for 5 minutes. I think it'll take just 5 minutes. I just need to.
Okay, so I'm gonna share now, and now I'm just gonna share on Reddit.
Yeah. Okay, can someone pick up the code? We'll debug it now. If not, you guys are welcome to debug it on your own. It's only going to take 5 minutes, I can tell you, right?
Oh, okay, do you have everything?
Chanya's got it. Yeah, I think she's got it in Xcode.
Okay, cool.
Xcode is more helpful than VS Code. It is telling us exactly what's going on, I think. Implicit instantiation. All right, mouse over that thing. It will tell you. It says it doesn't know about make musical name. It doesn't know that function. Where is team double colon? Where is your team.h? Go to the top again. Where's your team.h? Go to the top of this file. Hash include. Oh, you have it this way. I see.
I think we need hash include string on the header file, don't we?
Oh, I see. You have to, hash include. I think you have to. All right, there's two ways to do it. Okay, enter. Actually, just include hash include IO stream for now. The other way is to just include the part that is to do with strings alone, right? Which is a pain. That in the syntax is I don't know. I have to look it up. Right, that should make it all go. And you can fix that now. You can fix the syntax error. All right, okay. Yeah, it's a pity that Chris wasn't able to stay for this. Okay, it was just simple errors, and now it should go. All right, you should be able to recompile it now. Just save everything and recompile. Oh, you still have the error?
Yeah.
No. 8-bit.
Placing undefined template with a string char.
Can you clean and rebuild for a sec, Chani?
Clean.
Just go to your Xcode menu and then clean. I think it's Command K.
Command K.
So it's still there. Okay. So
Yeah.
implicit instantiation of undefined template, string char. Okay, hang on. Team. And it doesn't know the declaration of this guy here. All right, let's go to team. I want to go to the top of this file to see what this is. All right, this is team.cpp and it includes team.h. Okay, good. Okay, and vector.
So we don't need the vector here.
But team.h includes IO stream, right? Team.h
Yes.
includes. Okay, so team.h includes IO stream and also using namespace.
I just
Wait, there's another error here. Let's loop will run at most once. Okay, so there was an error here. Make musical name.
Never executed. What?
Oh, the num syllables. Yeah. Oh no. Yeah. Size. Dot size. Thank you. And thank you. That's very important. Okay. Good. So that's taken care of. Member reference name, size T.
should I just put int?
No. In your in his file, he is referring to size as size underscore T somewhere in his header file. If you look at the header file, somewhere he returns size T instead of size. Where's the size function? Bool set size. No, there it is. Yeah, I can see it. Bool set size T. Get dot size. Size T underscore size T underscore themselves. Some string. Okay. Get rid of that some string thing because that was there just for get rid of the line 15. Get rid of line 15. Yeah, delete that. Okay. Set player name looks good. Standard string that also returns and make musical name should return string. There's something very, very obvious that I'm just overlooking right now, which I'll probably know as soon as the lecture, if not during the lecture. Okay, but you guys should also feel free to. All right, the constructor looks fine. Okay, that's fine. Vector and IO stream hash included. Okay, team.h. All right, now let's look at the implementation file. Yeah, let's look at the implementation file. Okay, this is a static string team colon making it a name size. Oh, it's underscore num syllables, not num syllables. Yeah, I'm so sorry. On line 34, it's online. Here, do you want some cookies? Here, come. Va. Underscore num syllables. Did you get it?
Yeah, I get it, but the error is still there.
No, no,
Underscore
it's
num
like
syllabus. It should be.
No, it is
Yeah,
not. No. The parameter is just num syllables. That's fine. The parameter is num syllables. I think you changed the wrong thing. I'm sorry. I got distracted for a second. Okay, num syllables. That's fine. On line 34, it's not num syllables. It's not num syllables, right? On line 34, that is not. That is. What is the name of the vector? The vector is what musical notes dot size. I don't know what is the
Musical syllabus.
Oh, no, it is just num syllables, not dot size. I'm so sorry. We got totally mixed up. We want that many syllables, right? So I think he had it right before. Just get rid of that. He was just missing the underscore, and then get rid of the underscore. It shouldn't be underscore. All right. So okay, good. We're going from what was before, right? Why didn't it work? Size t equals 0.
Most ones.
No. Loop will run at most once. Okay, this is where it was before. One sec.
What's wrong with
No, there's something weird. Some brackets or something is funky here. You're having a return. Oh, you have a return. See, this compiler is so beautiful, isn't it? Okay, it tells us exactly what the problem is if we just look. Why would you return? So that's a typo. You did a return inside of the loop. So as soon as you enter the loop, it's going to return right there. So the return should be outside the loop. Yeah, and then get rid of the braces. Get rid of because there's only one line in there, right?
Oh.
All right, get rid of the braces. Here, come.
Yeah. That's good. String team, semi-musical name, size t, name syllabus, order of non-defined, size of double matching definition.
Did you? Oh, I'm sorry. Are you waiting for me? I didn't realize that. Sorry.
I think
okay.
the error on line 40 refers to, there's not a declaration in the header file.
Set musical name. I think it's.
Oh, what is that? Names.
Names.
S?
Names.
Yeah, there you go.
I see.
And then
Okay.
why is make username underline? Hang on. Is it make? I don't think
Make musical name.
Make music.
Make music.
Make.
Yeah, there you go.
We have so many typos.
Oh, make musical. Yeah. See, just all typos. Yeah, so we're good. I'll get rid of that some string equals hello because that was just an example Chris put in.
Yeah, so we can just remove the whole line.
Okay.
All right.
Yeah, I think we're.
That should work. Yeah, you can go to your main now and it'll work.
Mean no member set musical name. Yeah.
Set musical names.
Names, yeah.
Yeah, okay. And now we see who there's.
I think we
Is it
debug
working?
everything.
Is it working?
Yeah, there's no error showing.
Okay, so we don't know if it's working. There's no error. Okay, it could be a bad sign. It could be a really bad. Or this is good. Okay, good. Now let's go to your main. It should run. It should work.
But in the Xcode, I don't think I can compile two CPP files together. Can I?
No, you can. You just create a new project. I'll show you. Just create a new project for now.
Oh,
Create a new
beautiful.
project. Create a new project.
Non-static
2 seconds.
No.
Just create a new project. Brand new project. Create a brand new project.
Wait a sec. Call to non-static member function.
Yeah, it doesn't know. It doesn't know. It doesn't know the team class. Oh, you have team.h included. Just create a new project for now. Let's do it
New
proper way.
project.
New project. Yeah, file, new. Oh, it is there. It is there. Hang on just a sec. Okay, player class, main.cpp, team.hc. This should actually run in Xcode. Why does it say it cannot run? Team.h is included. call to
Auto
non-static.
non-static member function without an object.
Why does it think why does it think set musical names is not a static function? It thinks it is not a static function. Go there, go to the declaration. Why does it think it's not a static function? Oh, set musical names is not declared a static.
Oh, it's static.
So I need to add the static in
Yeah.
front.
Yes. Yeah, taren va.
Yeah.
Right? Now I think that should go. Team, you added the static keyword, right?
Yeah, I added.
Yeah, clean it and build it. I think it should build. Command B now. Command B.
Command B.
Command B.
Oh, Command B.
Command B is build. Okay, now it built successfully. So if you run it, it should run. If you run it, it should. What's going on?
Okay.
Yeah, if you run it, it'll print in 10 names. It'll print 10 musical names right now if you run it.
Nothing's there.
Did it run?
Yeah, I ran.
I didn't see any output.
Yeah, nothing.
No, you're not looking at the right place in the screen. Hang on. For I equals 0, I listen 10. What's going on?
Is my computer freeze?
No. Run again.
Oh, I saw something.
Yeah, I saw something too.
Oh, but
Go to the top. Run
We
it.
should
now.
add some verbosity.
No, it should work. You should just hit the triangle, run it. Command R to run it now. Or hit the triangle and. Why does it keep saying player? Why does it keep saying replace that thing each time?
It was running. Yeah.
Okay, there it is. There it is.
yeah.
Hey, why is your name
Okay.
so big? The first one, do me and
Do me T me re.
why is that name so long? Why are the names so all different lengths?
we
'Cause
said-
Have ender.
At least 10, right?
Oh,
the
each time you're calling it
length-
with a random thing. Just call it with 4. Just call it with 4. Okay,
Me
4.
change it.
Yeah, because otherwise it doesn't look so good. 4-letter names or 4-syllable names will be nice to pronounce, right? And then that you can also turn them into musical sounds.
Yeah.
There you go.
Dodom.
Yodomiti, Titimere, Reretimi, Doditola. So they all actually sound like real names, right? And the cool thing is you can actually play these names on a piano, right? You can choose a chord and play a scale and play. It's kind of cool. All right, cool. I think we got some nice things to do today, and we managed to complete, one part of what we wanted to do.
Yeah.
What we want to do next class. I think on Thursday when everybody's here. And it's kind of cool that we did this today because this is not directly related to what we're going to do in the core of the following lectures, which is really to learn about sorting and how classes can have arrays in them that can be sorted in different ways because we want to branch into sorting and searching slowly, right?
Yeah, we haven't covered the sorting, right?
You have trouble with sorting?
I'm doing the.
Oh, you're doing a quest.
Yeah, quest.
Yeah. Okay. All right. So you have sorting in quest number 7 and so on, right? But we want to move in that direction. So we didn't do any of that today, which is great because a lot of you are still in vacation mode, I think, right? So on Thursday, what we'll do is use this. Someone keep a copy of this. Chani, I don't know how you're going to make this available, right? Or you can bring it to next class. We want to use this to create a team in which you have n players, right? Each one of them has a random name generated by this guy that we just wrote. Yeah. Okay.
ID, name, and yeah.
Yeah, the random name. We've done all that so far already. And then we'll call srand. So each time it'll be different, right? And then we'll also say shuffle them so that's the order. That's the ranking, internal ranking in that vector, right? But that's not shown to the outside world. Only the team manager, or even the team manager doesn't know. Maybe he's in the outside where before he's hired into the team, right? He's in the outside. He's got to figure out who's good and who's bad before he makes it into the team, right? So the team manager is outside. He cannot see the actual rankings, but he can choose 2 players and get them to face off, okay, and make some notes, okay, and then choose 2 more players, make them face off, make some notes, okay, and then after a lot of these face-offs, using his notes, the team manager, if he's a clever guy, right, he or she should be able to identify the ranking of those players just by facing them off against each other. Yes or no?
Yeah.
All right, okay. So the challenge is going to be to create a game in which a team manager is so good that they would have the least number of those face-offs to make before they can make the correct decision. Because there's only one ranking and it's all shuffle. And a good team manager can determine the correct ranking, the Oracle golden ranking, with the least number of face-offs. And then the team manager is hired and becomes an internal member. They can look at the real rankings. Yeah, how's that? That's cool, right? And I think we can
Yeah.
pull it off. We can pull it off in a couple of classes. And this will set the stage for talking about sorting and then comparison sorting, right? Domain dependent sorting, like I said before, we don't even want to go in that area, right? Because it's useless, really. You can bring a lot of stuff into with domain knowledge. What we want to study is comparison sorting, which is, the best you can do with the least amount of information. And that's what our team manager is going to try and do. I think I kind of like this, I mean, maybe we should just work this into the modules or something, because that analogy is kind of fitting quite nicely, that you have this team and then, you have to determine the rankings just by making one query. That's one bit of information, right? One bit of for every pair. And I think that's kind of cool, ties into sorting nicely. Thank you all for your patience, right? And listening to me and getting this done, right? And it's actually a working program with the proper implementation, done everything done in one class, right? Chris should hopefully come back and look at his code. It's a pity because of typos, right? And you'll get better at it. Here's the thing, right? Initially, you'll find that a lot of your programming delay, right? When you want to get something done, you'll find that a lot of the time you spend is because of silly typos, right? Because that is invariable. And a lot of people will get confused and get the wrong picture and say programming takes a lot of time, right? It's not to me. There's a lot of routine, mundane work. There's a lot of, clerical checking and so on, right? They'll say that's not for me. I'm a higher level ideas guy and I can only come up with these ideas and someone else has to do the nuts and bolts thing. Right? But that is a wrong perspective if you think about it, because what can happen is that if you actually have the ideas, it's actually the best for you to do it yourself, because there's always, loss in translation, even to the best mind. There's always, so I think, and so how can you do it if you don't want to be bothered with the nuts and bolts? The best way to bring your ideas to life, if you don't want to be bothered by the nuts and bolts, is to just get familiar with the nuts and bolts so much that they just become part of the background noise, right? You don't see them anymore. And that's where we're going with all this, so that we actually build all these things out and it actually looks real enough, right? And you've got enough practice and you've run into all these typos and all these things sufficient times in your life, without me saying, hey, go and fix that typo, go and fix that. No, you don't have me going around you for the rest of your life saying, hey, clean up here, clean up here. No, right? So you got to get used to that, right? And the best way to do it is just make a lot of typos here, because you got to have them. You got to make a lot of typos, because the slowdown you experience because of typos has got to get painful, right? The slowdown in your coding that you experience because of typos has got to be so painful, not painful in a bad way, right? Because it'll slowly just vanish. It has to be painful enough for you to say, well, enough of that now, right? I don't want to be bothered with this in my conscious mind anymore. I'm just going to get used to it. I don't make this anymore. So automatically, every time you do, you just make sure that's the highest priority. It's the highest priority, but also easiest to check, 0 time almost. Right, so you just don't make any typos after that. See, that's why you see, when we're typing, I usually try and make sure, unless I can't see very clearly, I try and make sure we don't make any typos. Because as it is, think about it, right? As it is, programming is, is a mental feat, right? If designing a good program is a mental feat, like a mathematical proof. You have to devote a lot of cycles to coming up with the right logic and everything. And imagine, on top of all of that, you also had to worry about all this mundane shit that comes in your way, right? So I think that is the reason why we want to get around all of these as soon as possible. Like in your writer's life, right? The first 1,000,000 words are going to be like total trash. They say, write it and throw it away, right? So the first 1,000,000 programs, the first 1,000,000 tokens in your program, make all the typos you want. All right, thank you very much. Thank you very much for your patience. Right, so and you can absolutely feel free to use.
Okay, bye.
Bye. See you later.
See you.